Hi guys, welcome to my channel. In this video, I'll be covering different types of parsing techniques used in NLP. Whatever the topics that I'm going to cover in this video, I will provide all those topics and the timings in description. Before starting this video, please check in description. I will explain what is constituency based parsing, dependency based parsing, top down parsing, bottom up parsing, probabilistic parsing, chart parsing, and also I'll explain CYK parsing and hypergraphs. I will explain all these parsing techniques in detail. Guys, I have uploaded complete NLP subject tutorials. I will provide that link. In description you can watch from there. If you are watching this video for the first time, don't forget to like, share and subscribe to my channel. Let's get started. Before explaining various types of parsing techniques, at first you need to know what is parsing. Parsing in NLP means breaking a sentence into parts and finding how the words are related to each other. So parsing is like making a structure or tree of a sentence to understand its grammar and meaning. Guys, I will give a simple example so that you can clearly understand what is parsing. For example, there is sentence Nagendra playing game. So at first, parser will break sentence into parts like Nagendra playing game, 3 parts. And then parser will identify grammar like what is noun, what is verb, what is adjective, etc. So Nagendra, which is noun, playing, which is verb, and game, which is noun. So parser, after finding grammar for each part of the sentence, now parser will create tree-like structure. Because normally, verb part will be root. So playing is root. And Nagendra and game depends on playing. So Nagendra and game depends on playing, where playing is root word. So parsing is done by parser. So parsing means breaking sentence into various parts and then identifying grammar for each part. After identifying grammar, parser will create tree-like structure in order to understand complete meaning of the sentence. This is known as parsing. Guys, parsing techniques are mainly classified into 2 types. One is constituency based parsing and second one is dependency based parsing. And we can also use other parsing techniques like top down, bottom up, probabilistic, chart parsing and CYK parsing. It first of all explain what is constituency based parsing. We also call this constituency parsing as parse structure. In constituency parsing, we will break sentence into parses. Yes, normally in any sentence there are 2 parses. One is noun parse and next one is verb parse. I'll give one simple example. For example, there is sentence the boy eats mango. In any sentence, at first we need to find what is verb. In this sentence, verb is eats. So from verb, complete right side part comes under verb parse and left side part comes under noun parse. Here H stands for sentence. So sentence contains 2 parts. One is noun parse and next one is verb parse. So constituency parsing will divide complete sentence into 2 parts. One is noun parse and next one is verb parse. When noun parse contain the boy and verb parse contain eats mango. Next I will explain what is constituency grammar. Yes, constituency grammar will split sentence into constituents. Constituents are nothing but group of words. For example, if you consider the sentence the boy eats mango, constituency grammar will split the sentence into 2 constituents. One is the boy, which is one constituent, eats mango, which is the other constituent. Constituents mean group of words. The cat, which is noun parse, which is one constituent, sits on the mat, which is the other constituent. Next I will explain what is dependency parsing. Guys, dependency parsing will show word-to-word relationship. Guys, normally in any sentence, each and every word depends on verb. So we consider this verb as root. That is nothing but verb is head. So in dependency parsing, each and every word depends on verb. So we consider this verb as head and all remaining words are dependents. This is example, the boy eats mango. Here verb is eats. So eats is root word and boy is subject and mango is object. So both subject and object depends on verb. So boy and mango both depends on eats the boy. So the depends on boy. So dependency parsing focus on relationship between words. So in dependency parsing, we don't focus on parses. That is, we don't consider what is noun parse and verb parse. We just focus on how words are connected to each other. That is nothing but how one word depends on other word. Next I will explain what is top down parsing. Guys, in top down parsing, we'll start from root. That is nothing but we'll start from sentence and then we'll find grammar rules until we reach each word. I'll give one simple example so that you can clearly understand this definition. Guys, for example, there is sentence the boy eats mango. This is complete sentence. I already told each and every sentence contains 2 parts. One is noun parse and next one is verb parse. Here eats is verb. So from verb, complete right side part comes under verb parse and left side part comes under noun parse. So any sentence contains 2 parts. One is noun parse and next one is verb parse. If you consider noun parse contain the boy. the, which is determinant, and boy, which is noun. You can also call it as noun parse. So noun parse contain the, which is determinant, and boy, which is noun parse. And similarly, if you consider verb parse contain its, which is verb, or you can also call it as verb parse, mango, which is noun, or you can also call it as noun parse. So verb parse contain verb parse and noun parse. Now we got grammar rule for each and every word in the sentence. So noun parse contain determinant, that is the, and noun parse, that is boy. And similarly in verb parse, which is its, so verb parse, which is its, and noun parse, which is mango. Guys, you can also create tree for this. So sentence contain noun parse and verb parse, and where noun parse contain determinant and noun parse, where determinant is the and noun parse is boy. And similarly in verb parse contain verb parse and noun parse, where verb is eats and noun parse contain mango. History for top-down parsing. So in top-down parsing, we'll start from root, that is nothing but sentence. This is root. So in top-down parsing, we'll start from root and then we'll expand grammar rules, that is nothing but we'll find grammar rules until we find each word grammar rule. This is all about top-down parsing. Next I'll explain what is bottom-up parsing. The same example, if you write this in reverse order, then we call it as bottom-up parsing. I'll give example. So in bottom-up parsing, we'll start from words and then we'll combine them upward into parses until we reach sentence. That is nothing but we'll start from words and we'll expand until we reach sentence. These are words. We'll expand rules until we reach sentence. So same example, the boy eats mango, where the, which is determinant, boy, which is noun parse, eats, which is verb parse, and mango, which is noun parse. So the, which is det, boy, which is noun, eats, which is verb, mango, which is noun. And we consider this the boy as noun parse, det plus noun parse is noun parse, and eats mango as verb parse. So noun parse contain det, that is the, and noun parse, that is boy. And similarly verb parse contain verb parse and noun parse. We consider this both noun parse and verb parse as sentence. So sentence contain noun parse and verb parse. So same example, if you write this in reverse order, then we consider it as bottom-up parsing. So in bottom-up parsing, we start from all words and we will expand until we reach sentence. This tree for bottom-up parsing, the, which is jet, boy, which is noun parse, eats, which is verb, that is verb parse, mango, which is noun parse. The boy, we consider this both as noun parse, eats mango, we consider this both as verb parse, noun parse plus verb parse, we consider it as sentence. These tree for bottom-up parsing. Next I will explain what is probabilistic parsing. Guys, we'll use probabilistic parsing whenever there is ambiguity. Ambiguity is nothing but whenever single sentence contains multiple meanings. In the situation, we'll use probabilistic parsing. I'll give one simple example. In NLP, single sentence can have multiple meanings. So we need to generate multiple parse trees. We consider it as ambiguity. For example, there is sentence, I saw the man with a telescope. This sentence contains two meanings. That is, either I use a telescope to see the person, or I saw the man who is catching telescope. We don't know which is correct. So normal context-free grammar will create two parse trees. So from these two sentences, if you want to select only one sentence which is correct, you can do it by using probabilistic context-free grammar. So traditional context-free grammar will just generate all possible trees for each and every meaning, but we don't know which one is correct. To solve this problem, we can use probabilistic context-free grammar. So probabilistic context-free grammar is combination of context-free grammar plus probabilities. So sentence with highest probability is selected as correct one. So we'll select highest probability sentence as correct answer. I'll give one simple example so that you can clearly understand what is probabilistic parsing. In previous example, I saw the man with a telescope. That sentence contains two meanings. One is I used a telescope or the man had a telescope. For these two sentences, we have to find probabilities. At first, probabilistic parser will create grammar rules. This is sentence, I used a telescope. So here verb is used. So from verb, complete right side part comes under verb parse and left side part comes under noun parse. So sentence contain noun parse and verb parse, where noun parse contain pronoun. Pronoun is I. So I is pronoun. And again verb parse contain used, which is verb parse, and we consider this a telescope as noun parse. So again verb parse contain verb parse and noun parse. So here verb parse is used, and again noun parse contain a telescope, where A is determinant det and telescope is noun parse. So determinant is A and noun parse is telescope. At first our model will find grammar rules for each and every word in a sentence. Guys, by giving millions of examples, we'll train our model. So whenever we give any sentence, our model will automatically generate probabilities. So by reading the sentence, our model will understand probabilities. Automatically it will generate probabilities. For example, for this sentence probability is 1.0, and for this noun parse probability is 0.3, and for verb parse probability is 0.6, and again for noun parse probability is 0.7. For example, randomly our model will generate probabilities for all grammar rules. So probability of sentence plus noun parse verb parse. First one into probability of noun parse, that is pronoun, into probability of verb parse. Verb parse contain verb parse and noun parse, into probability of noun parse that contains determinant and noun parse. So that is 1.0 into 0.3 into verb parse, 0.6 into 0.7. If you multiply all this, you will get result as 0.126. So for first meaning, we found probability. And similarly, we will find probability for second one, that is the man had a telescope. So sentence contain noun parse and verb parse. Noun parse contain determinant the and men, that is noun parse, and determinant is the, and next noun parse is man, and verb parse contain had a telescope. So here had, which is noun, and again noun parse contain a telescope. So noun parse contain determinant and noun parse. Determinant is a and noun parse contain telescope. So automatically whenever we give this example, automatically our model will generate probabilities. As already model is trained with various kinds of examples, that is millions of examples. So whenever we give any sentence to our model will automatically generate probabilities. So this is probability. So for sentence 1.0, for noun parse 0.7, for verb parse 0.6, and for noun parse 0.7. So probability of entire sentence is nothing but probability of this rule, this rule, this rule, and this rule. That is 1.0 into 0.7 into 0.6 into 0.7. That is 0.294. After generating probabilities, our model will create constituency tree. That is nothing but we to represent these rules as tree structure. So sentence contain noun parse and verb parse. Noun parse contain pronoun, that is nothing but I, and verb parse contain verb which is used, so verb, and as well as noun parse. We consider this a telescope as noun parse. So verb is nothing but used, and again noun parse contain a telescope. So A is det and telescope is noun parse. You can also write noun or noun parse, no problem. So again noun parse contain a telescope. A is det and telescope is noun parse. So det is A and telescope. These three, I used a telescope. And similarly for second one, the man had a telescope. So complete sentence contain noun parse and verb parse. At first we need to find what is verb. This is verb. So from verb, complete right side part comes under verb parse and left side part comes under noun parse. So sentence contain noun parse and verb parse. Noun parse contain determinant and noun parse. So noun parse contain determinant and noun parse, where determinant is the and noun parse is man. And again verb parse contain verb parse and noun parse. So verb is had, and again noun parse contain a telescope. So A is det and telescope is noun parse. Det is A and telescope. These are trees. So for sentence 1, probability is 0.1, and for sentence 2, probability is 0.2. When compared to 0.1, 0.2 is highest. So we need to consider second sentence as correct sentence. That is, the man had a telescope is correct. This is all about probabilistic parsing. Next I will explain what is chart parsing. Guys, in chart parsing, we will maintain chart, that is nothing but we will maintain table that contains all grammar rules for all combinations. So next time whenever we get similar sentence, instead of finding grammar rules again, we can simply check that chart and we can find rules, which will save our time. So in normal parsing, parser may parse the same parse many times. That is nothing but for same sentence, we need to do parsing many times, which will waste our time. So chart parsing stores already parsed subparses in table so that we can reuse it, which will save our time. I'll give one simple example so that you can clearly understand what is chart parsing. As for example, there is sentence. The man saw the telescope. At first, we need to find grammar rules for this sentence. After finding grammar rules, we'll store all combinations in table. So we can reuse the table whenever we get similar sentence. This is chart parsing table. This is complete table, right from reverse order. The man saw the telescope. This is complete sentence. Verb parts contain saw the telescope. So saw, which is verb, the, which is determinant, telescope, which is noun. Similarly, noun parts contain the man. So the is date, man is noun. Like that, we need to store all combinations in one table. So whenever we get any similar sentence, instead of finding grammar rules again, simply we can see this table and we can check grammar rules. So we created chart parsing table for this sentence. The man saw the telescope. For example, next time I got sentence, that is saw the telescope. Instead of finding grammar rules for this complete sentence again, simply we can check this table and we can find grammar rules. For saw the telescope, directly we can check this table, that is saw the telescope, which is verb parts, saw, which is verb, the, which is date, telescope, which is noun. Like that, simply we can find grammar rules instead of finding grammar rules again. This is all about chart parsing. In exam, you can also write chart parsing table diagram like this. So simply you need to include all combinations in boxes and we need to connect them with grammar rules. Next I will explain what is CYK parser. Guys, CYK stands for Cocke younger Kasami. CYK parser is also one of the type of chart parser. The CYK parser will work along with CNF. For example, there is sentence. The man saw the telescope. At first we need to find grammar rules. So sentence contain two parts. One is noun parse and next one is verb parse. So from saw, complete right side part comes under verb parse. So noun parse contain the man, where the is determinant, man is noun parse. So noun parse contain determinant the and noun parse, and verb parse contain verb, that is saw, and the telescope, noun parse. And again this noun parse contain the, which is date, telescope, which is noun parse. So date is the and noun parse contain man and telescope and verb parse contains saw. So at first we need to find grammar rules for each and every word in the sentence, and then we need to draw table. In this table, at first we need to arrange each and every word. The man saw the telescope in row wise and column wise. So we need to arrange each and every word in row wise and column wise. So the, which is date, and next man, which is noun, saw, which is verb, you can check here, and next the, which is determinant, and next telescope, which is noun. So we need to arrange each and every word grammar rule diagonally. Guys, we consider the man as noun parse. So we will combine these two. The man, which is noun parse. So noun parse is combination of determinant plus noun parse. And similarly, the telescope, we can combine this both. So we combined the man and the telescope. Determinant plus noun parse. You consider this both as noun parse. So from verb parse, we combine these two. So saw, which is verb plus noun parse, the telescope. We consider this both as verb parse. So noun parse contain the man, we combine this both. Verb parse contain the telescope, we combined the telescope plus saw. Saw is verb, so combining saw, verb plus noun parse. We consider this both as verb parse. Now we'll consider sentence. So sentence contain noun parse and verb parse. So we'll combine verb parse and noun parse. We consider it as sentence. So sentence contain noun parse plus verb parse. So simply by checking this grammar rule, we can create diagram. Guys, in CYK parser, we'll start from each word and then we'll combine grammar rules until we find sentence. So we consider the CYK as bottom up parsing. That is nothing but starting from words, we need to bring sentence. That's an exam. You can also write steps. In step 1, we found grammar rules for each word. And then for the man, the telescope in next step. And for third step, saw, the telescope. And fourth step, will come and complete sentence, that is noun parse and verb parse. This CYK tree, sentence contain noun parse and verb parse. Noun parse contain the man, date and noun. Verb parse contain verb, which is saw. And again noun parse contain the telescope, where the is date and noun, telescope. This is all about CYK tree. As in exam, you may also get separate question, that is nothing but what is hypergraph. Guys, if we connect more than two nodes at once, that is nothing but if we connect more than two words at once, we consider it as hypergraph. This is example. For example, there is sentence. The man saw the telescope. So noun parts contain the man. We combine this both. So we consider it as hypergraph. And again noun parts contain the telescope. So we consider it as one hypergraph. And verb parts contain saw the telescope. As we are combining saw the telescope, we consider it as verb parts. This is one hypergraph. And complete sentence. The man saw the telescope. As we are combining multiple nodes at once, we consider them as hypergraphs. So here each production is one hypergraph. So whenever there is any similar type of sentence, simply we can reuse these hypergraphs.